So today we're going to be identifying exponential and logarithmic functions. We're going to solve exponential equations. We're going to solve logarithmic equations, and that's about it. So what the heck is an exponential equation? An exponential equation, again, is just any equation that has a variable in the exponent. How the heck do we solve exponential equations? Basically, we get the stuff with the exponent by itself, and then we take the log of both sides. Why do we take the log of both sides? Well, if you take the log of both sides, you're going to have the log of a base to a power, and you can use the power rule to get rid of the variable out of the exponent. But what if there's more than one exponent with a variable? Well, then we're going to need to try to write out each of these exponentials with the same base, and then we're going to set each exponent equal to each other. So if two powers with the same base are equal, then their exponents are equal. That's it. Yeah, still need to be able to solve for a variable, but we already know how to do that. And then what the heck is the logarithmic equation? A logarithmic equation is just any equation that contains the logarithm of a variable. So how do we solve for these? We're going to get that logarithm by itself, then rewrite the log in exponential form. And then if there's more than one log, we need to use the product, the quotient, and the power rules to combine the logs before we can rewrite exponential form. So rewrite the log in exponential form. Anything else? We just need to simplify the exponential form and solve for a variable. But again, once you're to that point, you should be able to solve for the variable without a whole lot of trouble. Alright, so we got a few examples on all of this. There's not a whole lot of me talking past this, but there's enough examples. Alright, so I'm going to try to get through A, B, C, and D on this video, and then I'll do the other half in the next video. Alright, so on A, I've got 16 to the 3x equals 8. I noticed that I've got the stuff with the exponent completely by itself, so I'm going to go ahead and I'm going to rewrite this as logarithm. So I should get log base 16 of 8 is equal to 3x, because again, the whole goal of rewriting it as a logarithm is to get the exponent out of the exponent. We're trying to solve for the exponent because we don't usually know what the heck that is. Alright, and then when you use this fancy thing called change of base formula, so then we've got log of 8 divided by log of 16 is equal to 3x. We type that into a calculator, and then we probably divide that by 3. Alright, so typing that into a calculator, I get 0.75 equals 3x. So then dividing both sides by 3, I should get x is equal to 0.25. Alright. The next part, I have log base 3 of 4x minus 3 is equal to 2. So again, I've got the logarithm by itself because everything that I see on the left-hand side is in parentheses, meaning that it's attached to the logarithm itself. So I just need to change this straight into an exponential function. So again, my bases and of my logs are going to match, so I should have base of 3 still. Exponent's going to become what's on the right hand side of that equal sign in this case is equal to that 4x minus 3. Alright, the goal of changing it to an exponential is usually I've got an x somewhere in here that I need to solve for, so I want to try to get to that as quickly as I can. So, simplifying this, I should get 9 then is equal to 4x minus 3. Add 3 to both sides, I should get 12 is equal to 4x. So then, dividing both sides by 4, I should get x is equal to 3. Alright, then the next one we've got 5 minus 3x to the x is equal to negative 40. So I want to get that 3 to the x completely by itself first. So what's attached to it is what I need to get rid of. So I need to subtract that 5 over. So I should get negative 3x is equal to negative 45. Alright. And then I don't like negatives out in front. So technically what I've got sitting here is I've got negative 1 times 3 to the x equals negative 45. So I'm going to divide off that negative 1 as well, which will just change my signs basically. So I've got 3 to the x equals 45. Alright. From there, I've just got log base 3 of 45 is equal to x. Again, the whole goal behind that is to try to get the stuff in the exponent by itself. That way we can solve for x, because again, the dead giveaway that it's an exponential is that we've got an x in the exponent. Sometimes it's a different variable, but generally it's an x in the exponent. Alright, so then all we gotta do is type that into the calculator using a change of base formula. So then we've got log of 45 over log of 3 is equal to x. Type that into a calculator. You should get x is approximately 3.4650. Because it was 3.46497, so the 7 would round the 9 up to being a 0, but then the 9 would round the 4 up to being a 5. Please don't forget how to round. Alright, next part. Alright, the next part, I've got log of x minus 3 plus log of x equals 1. Well, the really cool thing is that last chapter, or last section, sorry, we learned about log rules. So it says, hey, I've got addition here, so addition's just gonna change to multiplication. So really I can combine this into being one logarithm. So I would have log of x times x minus 3 equals 1. Alright, well we can do this. So really what I've got is a base of 10 if we don't see a log here, for those of you who don't remember that. Other than that, I can distribute this just like I did in Algebra 1, which would give me log base 10 of x squared minus 3x is equal to 1. Which then I can go ahead, and since I've got the log stuff completely by itself, I can change this into an exponential. Changing this into an exponential, I get 10 to the first equals that x squared minus 3x. Alright. And then, oh no, we've got a quadratic. So I've got, simplifying this, I've just got 10 is equal to x squared minus 3x. And then remembering back from Algebra 1 and Algebra 2, if I have a quadratic, I don't want that to equal a number most of the time. Well, in most situations, unless you really like completing the square. Which, seeing that there's a 3 in front of that plain old x, I really don't want to be cutting that half and squaring it and adding that to both sides, to be completely honest. So honestly, I'm probably going to try to factor this. So subtract that 10 over, I should get 0 is equal to x squared minus 3x minus 10. Alright, so then factoring this, what multiplies to negative 10 but adds to negative 3? Well, that would be a negative 5 and a positive 2. Alright, and then we just have an x and an x that go in there. So then I would plug in and solve for x. So I'd get x is equal to 5 and x is equal to negative 2. Plugging these in to make sure they work. I get log of 5 minus 3 plus log of 5 is equal to 1. That one checks out, so that one works. And then I need to plug in negative 2. So then I get log of negative 2 minus 3 plus log of negative 2 is equal to 1. Alright, and then there's a problem because we can't take the log of negative numbers. So that negative 2 doesn't work, which means that it is what we call an extraneous solution. So again, how we mark extraneous solutions is that we circle them and we put a line through it. Easy enough. Just make sure I can tell that that's still negative when you cross it out. Alright, other than that, I will see you in my next video.